Okay, guys, here's an update to the video that is already posted because I realized that we can do this a better way, at least way we set up the equipment this time. Last time we used only three apparatus, three ramps, and then we tried to make them identical. This time we didn't do that. So it looks slightly different. I have group 5 here. They're the only people, well, at the time I made this, that uploaded their data. So I downloaded it from the Google Sheet, and I said save as. Pause. All right, so I'm back at the Google Sheet, and I see that. Oh, look at that. Everybody entered. All right, good. Oh, and they've done their work here. All right. Right. It's not exactly what I wanted, but and the first thing you do now is to make a copy. Here we are. Download, and I want to Microsoft Excel, and there it is. And I've already done that. But one thing I forgot to do is to save it with my name in the file. Here's what I downloaded the other day with just this group. So I'm going to say save as, and let's see what, I really hate this. I never use this. I always go to browse. I need to go to the folder where I keep my work, Phys 2100 lab, statistical analysis of data, and then I just want to add my name to it. Dr. H. Oops. Okay, so I'm going to misspell this one. Let's get rid of that. So what do I have here? What I'm going to do is I'm going to create this a residual. So I'm going to insert a column, and I think I like it's. If I add extra here, that means that it takes up more room, but then I have a clear column in between. So residual wols, I guess. And in this case, it's going to be data minus prediction. Huh? So I've already done it once. And notice I need to use the dollar signs so that it always references the predicted value. And I'm doing data minus prediction. So if it's positive, then the marble went too far. If it's negative, the marble fell short. So equals data minus the prediction of 71.6. I hit the F4 key, and there we go. And the reason we're going to do this is that, and I noticed that this is a repeat of the one on top here. So I'm going to clear that out. The reason I'm going to do this is because this is going to be our normalization. We're going to all compare the difference between what it's supposed to do and what it did do. And and I mentioned it in class, but we're doing it a slightly different way because I realized that we can just do the standard deviation and error on the residuals. We don't have to do that error propagation formula that I mentioned. I do that all the time when, oops, I don't want to insert copied cells, so how do I, yeah, this one draw, I don't know how to, once there's some on the clipboard, then Excel and Word, and I don't want that, I just want to insert a blank column. Heck, I don't even know what it's doing, look at that. It's in La La Land. Come on. Oh. Wow. I wonder what that's all about. And I'll just delete that because it took for, I think it pasted it like into infinity. So let's see, we got residuals, so now we need insert here, and then insert here to get the space between. Okay, so now we can, let's see what happens if I copy and paste B14, BI4. Okay, good, it works. And then I need to, let's see if it'll allow me insert here. And then, will it let me paste? No, I have to, it nuked what it was ever on the clipboard. Copy and paste BM. Good. All right, so I want to fill this in. And I want to fill this in. All right. Wow. So I wonder if this group randomized enough, because it looks like set 4 is really off. So you guys are going to have to do some quality control. Okay, so the variance, remember, is equal to the, oh no, first we need the average value. Okay, so, all right, so average is equal to average, open the parentheses. Now, I've selected these, right? So now I hold down the control key and I do it again. And I do it again. And so let's see, I should be able to just slide this over, and I'm still, so I let go of the control key for a moment. Now I've held it down again. Yeah, this, I think something's wrong with this last set of data. If it was me, I would delete that, but let's see, you never know. Then I close the parentheses. You see now it's got all those columns. And now I've got the average. Well, not bad. Not bad. Minus half a centimeter. Nice. All right, so now the variance is really the sum, so that's why I put it in parentheses. That's going to equal to the data point minus the average, and then I do that, and I need F4, dollar signs. And then I close it, and then I have to square it. Good. Yep. Okay. So now I'm going to use the fill handle and copy. Let's see what happens when I do paste. Oh, that's nice. It did the whole column for me, huh? Sweet. EF22. Yep, it's working out. And now we paste and paste. All right. So the standard deviation of the sample is equal to the sum of all those things. All right, wow, look at the size of that one. Yeah, but even so, it ended up being a reasonable average. So now I'm holding down the control key to get this. Yeah, and that. Close. Now, I have to divide it by the number of points minus 1. So this is, we use this function called count. And we go ahead once again and select those columns. I hold the control key. And so 3 times 24, or 4 times 24, should be 96, if I'm not mistaken. And then I close that, then minus 1. Okay, that's the denominator. Now I have to square root it, so I'm going to click over here. SQRT, yeah, and close it. And that's the standard deviation of the sample. Wow, not bad. And I want to just keep 2 decimal places. So I formatted it. Now I want to get the standard error, which is just dividing that by the square root of the count. Oh, so I'm going to get clever. I'm going to copy this. Count. Yep. And Control C. All right, and I hit the escape key. And the standard error is equal to this divided by the square root of the number of measurements, was this count, Control V, close the parentheses for the square root. And it didn't like this. Oh yeah, I needed another parentheses, it looked like. Yep. Okay, good. And look at that. That is quite good. Even with that 4th column that I was a little suspicious of. Well, it's not the greatest fractional error. It's 0.2 over 0.5. But let's make that 0.47. So it's 0.47 plus or minus 0.2. So, okay, so that's a 20% fractional error. Then we'll see who gets the best. I personally think that, well, yeah, they're all negative, and I might just throw that one out. And maybe that, one thing could be this group had 3 people, and they forgot. No, I put this up as blank. I wonder what happened. Okay, so now this is we did by ourselves. So now what we're going to do is we're going to double check. We're going to use the built-in function in Excel to see if it gets us the same number as we got. So equals stdev dot s, see? And now we have to pick all those columns again. So I gotta have I'll put all of them on the page, so just a little bit easier. Okay, so now I'm holding down the control key. Oh, wait a minute, wrong one. Oops, let's see what happens. No, I'm not gonna let go of the control key. So now it just switches over here. Okay, now I'm gonna hold the control key down. And yep. And again. And I close the parentheses. And look, that comes up the same. I gotta format these. Number. And so that's great. So let's double check the standard error. STERR. And this is going to equal this. Well, it's got to be the same because it's going to be divided by the same thing. And so that's going to equal this divided by the RT. And I just happen to know it's 96, so I'm just going to put that there. And it should come out. There it is. Wow. So now what we've done is we verified that the standard deviation of the sample function in Excel does what we expect it to do. Okay, so we'll talk about this some more in class. Of course, you'll probably see this after class, but now we've zeroed in. So you don't have to analyze the other groups anymore like you had because we instantly normalized our data by using the difference between the data, the predicted minus the actual. Well, it's the data minus the predicted, the actual minus the predicted. All right, see you all soon.